Hi, I'm Christina, and later on today you're going to be meeting my colleague Tim. I'm sure you're familiar with what I'm holding in my hand, the bottle cap. Today we're going to talk about how pollutants, like a bottle cap, can enter the Long Island Sound and affect the animals that live there. Have you ever seen a sign like this before? This sign is telling us that the shellfish beds are closed. But why exactly would they be closed? Well, it's to prevent people from getting sick because these animals might be contaminated with pollutants. Pollutants can get into the water in many different ways: point source pollution, runoff, or even from the air. These animals confuse pollutants as food and they start to consume them themselves. From the smallest animals such as a copepod all the way up the food chain to the whale, all these animals can be affected by consuming pollutants.
In order to understand how a pollutant could travel its way through a food chain, we first need to understand the food chain and the wide range of biodiversity in the Long Island Sound. The base of the Long Island Sound food chain is phytoplankton, also called plant plankton. These plankton photosynthesize, taking the sun's energy and turning it into edible energy. Plant plankton are commonly eaten by animal plankton called zooplankton. There's a large variety of animal plankton, but one common example is the copepod. Small crustaceans like the copepod are often eaten by small fish like silversides. The silversides then get eaten by larger prey fish like flounder and striped bass, who eat constantly. Those larger fish are then consumed by humans and some predatory birds like this osprey, who dives for the fish it eats. The Long Island Sound alone has over 120 species of finfish and 50 species of fish that spawn in the Sound. This makes understanding the food chain and the way animals interact with one another in their environment extremely important.
When living things are in polluted water, they can breathe, absorb, or eat the toxins that are in that water. This is called bioaccumulation. These animals accumulate the toxins faster than they can eliminate them.
In addition to toxins and pollutants that are easy to see with the eye, there are also ones that have made their way into Long Island Sound that are not so easy to see. Chemicals like DDT, which is a pesticide that was applied to kill insects around Long Island Sound, have found their way into the food chain. Just like affecting the insects it's targeting, it also affects animals that have similar body structures, like the horseshoe crab, that live in Long Island Sound. The problem with DDT is that it has a low solubility rate, meaning that it doesn't mix well in water and doesn't break down easily. DDT takes 15 years for half of it to break down, meaning if you have 100 pounds of it today, 15 years later, you still have 50 pounds of DDT left in the water. This particularly affected ospreys, which are a type of hunting bird. The DDT made its way into the fish that the ospreys like to eat, and it ended up affecting the thickness of the osprey shells. These were almost extinct in this area. Fortunately, DDT was banned, and the ospreys have made a great comeback.
Another term that is closely related to bioaccumulation is biomagnification. Both words can be easily mixed up. While bioaccumulation is when a toxin builds up in an animal, biomagnification is when the toxin increases in amount each time it moves up the food chain. If you break down the word biomagnification, bio means life, and to magnify or magnification is to make something bigger, such as when you use a magnifying glass. So as you go up the food chain to the bigger animals, the amount of toxin becomes larger and much higher. In biomagnification, there might be a low amount of toxin in the organism that originally absorbed it. But then, that smaller organism is eaten by a larger one. And since the larger one probably needs to eat more than one of the smaller organisms, the toxin levels become higher in the animal's body. For example, first a fly absorbs a chemical, and then the frog eats that fly. And that frog is very hungry, so it eats more than one fly. Now there's a lot of toxins in the frog's body, at least more than the fly originally had. Then a third large animal comes along, such as a snake, and that eats multiple frogs. Now the snake has even more toxins than the frog did. When the large animals at the top of the food chain, such as a snake or even a human, accumulates all the toxins from the smaller animals, it can become life-threatening.
Not all toxins in the water are chemicals. Can you think of one you can't see with the human eye, but is one of the main pollutants? Microplastics. Microplastics are the breakdown of those large plastics. They're less than 5 millimeters in size, And what breaks them down is the sun, wind, and waves. I have 4 items in front of me that all break down at different times and at different rates. Can you hypothesize how long it takes a straw to break down, a toothbrush to break down, a plastic bag, and the bottle cap? Let's start with the straw. The straw takes 200 years, our toothbrush 400 years, our plastic bag 500 years, and the smallest item on the table takes 1,000 years to break down into those tiny particles. Scientists are finding these microplastics throughout the water column due to currents. Now, they may be small, but they're causing a huge problem with the animals that live in the Long Island Sound.
Animals in the Long Island Sound are beginning to confuse plastic for their food. Starting at the bottom of the food chain, it may be difficult to see, but in this aquarium, there are zooplankton. Zooplankton have specific feeding appendages that take in a certain particle size. Microplastics are a similar size to the particle size that they eat. That means that they're accumulating those microplastics. In this tank, we have mummichogs. Mummichogs like to eat zooplankton like the copepod. A mummichog can eat 100 copepods a day, and if each one has a single piece of plastic, that mummichog now has 100 pieces of plastic inside of it. The diamondback terrapin is a type of turtle that lives in the marshes that the mummichogs also live in. When they go hunting, they may eat 3 mummichogs. If each of those 3 mummichogs have 100 pieces of plastic, the diamondback terrapin now has 300 pieces of plastic, 300 times more than the copepod that first accumulated that plastic. This is how biomagnification is occurring in the Long Island Sound.
What are people doing to prevent bioaccumulation and magnification from occurring? Some laws have been put into place to prevent toxins from entering the Long Island Sound in our environment. For example, in 1972, DDT was banned from the United States, and we have seen significant impact from this. We have seen lower toxin levels in our environment. What are some things that you could do at home to prevent toxins from entering the Long Island Sound? You can stop using fertilizers and pesticides on your lawn. You can use a reusable bag or water bottle and ditch those plastic straws. This small bottle cap may seem insignificant, but in the long run, it can harm the Long Island Sound, animals, and even us.